Thank you, everybody, for joining. My name is Yosef, and I have with me Cornelia, and we are going to walk through how you can use Temporal with Pulumi to orchestrate some really cool use cases that expand to application development and production infrastructure management. All right, this is me. I'm Yosef. I've been a solutions engineer for over 6 years. Started over at Oracle, did some time at Okta, and then now working at Pulumi. I've been at Pulumi for about a year and a half almost. So happy to be here and talk to you about how you can use Pulumi to make your DevOps infrastructure management life a whole lot easier. And I'll pass it over to Cornelia.
Yeah, and thanks so much, Yosef. My name is Cornelia Davis. I'm a developer advocate at Temporal. I've been doing this, I have a lot more gray hair than Yosef just talked about. I've been doing this for a long time. I have spent, I'm seeing something here that says, can you make a little bit louder? I don't know if you mean both of us. If you could, Serge, if you could say something about that, if that's any better. But to continue on with my intro, I have spent, at least the last 15 years or so in developer platforms. I was at Pivotal for quite some time, worked on Cloud Foundry for a long time, then Kubernetes was kind of around when the whole microservices movement happened. And so wrote a book about microservices and distributed systems called Cloud Native Patterns. And I've been at Temporal now for, 4 or 5 months. It's a great distributed systems tool that I'm so excited to share with you today.
Perfect. Thank you. So we'll keep moving forward. Our agenda for today is just to do a brief slide introduction to both Pulumi and Temporal. And then we'll get into kind of the live use case that we've cooked up for you all. And so I think you'll be really excited to see what we've made. We were proud of it, and I'm sure you'll be too. And then last but not least, we'll have Q&A. There's going to be a little bit of space in between the demos as well. So we might ask for Q&A where we can check in with the chat there too to see that if there are any we haven't answered. All right. So we'll get started with just a quick overview. I say quick. I will try to make it quick, but a quick overview of Pulumi. And so Pulumi is at the core, an infrastructure management tool. And we've certainly grown to include additional aspects of infrastructure management. But some of the main reasons or challenges that people come to Pulumi or are looking to implement an infrastructure as code tool is that they're hoping to reduce complexity, right? If they have a lot of cloud resources that they need to deploy, and sometimes those take some trial and error, it's better to have them in code versus ClickOps or scripting in that case. Another one is to accelerate time to market. So if you have these pre-built infrastructure architecture already up and running, then you just need to focus on your application instead of worrying about standing up infrastructure every time you need to deploy something. And then last but not least, it's to increase productivity. So your DevOps organization or part of your team can handle any of the infrastructure stuff and even surface that up to developers through an internal developer portal. Now, like I said, Pulumi originally started as an infrastructure as code tool, but we have certainly grown to include a lot of different capabilities that surround your infrastructure management goals, right? So the first thing is Pulumi IAC. And some of the main things to know about Pulumi IAC is that you're able to author in imperative languages. So you can use things like Python, Go, TypeScript, as well as any of the programming paradigms that you might already be familiar with. So like for loops are really easy, whiles, conditions, unit testing, all of that stuff can be achieved through IAC, all while still being a declarative tool, right? So you don't have to worry about kind of order of operations in resource creation. Pulumi ESC is our infrastructure configuration and secret store. So you're able to author directly in ESC, but you can also dynamically pull credentials from external sources. Like, for example, if you're using AWS Secrets Manager, you can use Pulumi ESC to pull secrets from that endpoint, essentially. Insights gives you the ability to get a single place to go and view all of your cloud resource creations. And so this can work towards day 2 operations, and as well as even help you migrate from a ClickOps structure or setup to a IAC with our import capabilities. Last but not least is IDP, and this is our brand new release. It came out early May, and essentially it's a self-service platform for developers to request infrastructure from the team, from the platform team, so that the organizations don't have to build them themselves. Across all of these, we have some cross-cutting capabilities. Copilot is our AI injection to the platform. CrossGuards are policy as code engine, so you can enforce policies on resource creation. And then last but not least is deployments, and this allows you to orchestrate execution of Pulumi programs. We're going to dive a little bit deeper into some of the detail here, and we're going to focus mainly on the Pulumi program model in this case. So at a high level, there's 3 things that you need to know about Pulumi. There is the project, and this is basically the directory in which your program exists. The project contains high-level metadata like the runtime, if it's Node, if it's Python, so on. The program, of course, defines those resources, and so this uses our providers to create the individual resources. And then last but not least is the stack. And you can imagine a stack being an instance of that program. So you'll see here that in parentheses, there's dev, stage, and prod. So imagine you're standing up a database. You might have your dev database, you might have your staging one, and you might have your prod one. Those stacks will contain the unique configuration that makes it a dev, stage, or stack prod configuration. I'll keep moving. So this is kind of the bare bone structure to know about Pulumi program. One thing that we'll also show as part of this demo is the use of automation API. And this is particularly unique to Pulumi. And what the automation API lets you do is basically stand up infrastructure through a library as opposed to through the CLI. So instead of going to your terminal and doing a Pulumi up, you can just do a stack.up in your applications or your portal or what have you there. So this allows organizations to orchestrate complex rollouts, can stand up their own self-service portals if they would like, as well as make any custom tools. So some folks create their own CLI based on what they need, but certainly that makes it available to everybody. The only distinction between a automation API program and a standard Pulumi program is it contains a workspace. And so if you can think of the original program model, just wrap it around in a workspace, and that's how you'll be able to invoke it through a program that you author. There's 2 types of workspaces. There's the local workspace and a remote workspace. The local one supports the code being inline. So when you author a automation API program using a local workspace, you provide the program as part of the code itself. Remote workspace allows you to store the Pulumi program in a GitHub repo, so that instead of having it in your application code base, it just reaches out to that GitHub repository, executes that Pulumi command from that repo. Any questions on the Pulumi overview? And I don't see anything in the Q&A, so I'm hoping that meant I did well, but I'll pause. Okay, all right, Cornelia, I'll pass it over to you then. You are muted if you are speaking.
Oh, yes. There we go. That's what I was saying is like hand it over to me. So if you can stop your screen share, or maybe I can steal
Yes.
it from you.
Yep, you're right.
I am going to go ahead and share my screen. Super. And we'll pick up here with the temporal overview. We did the little switchy thing on the slides because we're also going to be doing live demos. So we're going to go back and forth. So let me give you, I think many of you, particularly since this is a Pulumi hosted webinar, many of you are probably new to temporal. Maybe you already know a little bit about Pulumi, but let me give you a little bit of an overview of temporal. And to set the stage, I want to talk about, like I said, I've been doing this a long time. And a while ago, we used to have architectures that looked like this, that were like these three-tier architectures. We had a database layer, a services layer, and a client layer. And if one of the lower layers went kapoof, then the upper layers could shrug their shoulders and say, wasn't our fault. And customers would by and large buy that. Because that's the way architectures worked. And we worked very hard to keep these services and these clients and even the databases up for many, many days in a row, many months in a row. But things have evolved, and now we live in this microservices world where those service instances, I think I heard once, they on average containers stick around for minutes, certainly not days or weeks or hours or weeks or days. Um, and the idea here is that as a user is going through their experience, they're going to service instances. If one of those blows up, we have to move their traffic over to a different service instance. And here's the trick is that developers had to build a whole bunch of stuff, a whole bunch of patterns. And as I mentioned, I kind of lived through this microservices era, and we learned all these patterns together. And they had to implement things like retries and circuit breakers and those types of things. And here's a whole list of those different patterns that needed to be implemented. And so, yeah, we got more resilience, but our architectures and our bill of materials got way more complicated. So if we wanted to create something like order processing, for example, how did we do that? Well, we had all these different microservices on the right-hand side. When we wanted to call a payment processor, that was a synchronous request. If it failed, then we needed to implement retries. As soon as you implement retries, you know you need to put some circuit breakers in place because otherwise you can DDoS yourself. For asynchronous work, well, you're going to add Kafka and you're going to add some topics and manage those topics. Oh, you've got another step, more topics, more management. And oh, by the way, I want to manage my state through all this. So I'm going to externalize my session state into Redis. So you can see that the whole thing got a whole lot more complicated. We implemented all these different patterns as a developer ourselves. So here's what Temporal does. Think of Temporal as a backing service, just like Redis or Kafka would be a backing service. All of your scale out services are connected to that backing service. And as you go through your code, and we'll see this running in action in just a moment, as your code executes, as your business app executes, or we'll see later, your infrastructure tooling, your infrastructure orchestration, as that executes, your code is in communication with the backing service to do things like implement durable retries, implement event-driven architectures. So all that queue management done for you behind the scenes, implementing that state preservation, all done behind the scenes. And you'll notice here that in addition to this little temporal service that you see in the back end, there's also a little, peach colored thing attached to each one of the services. Well, that is a part of temporal, and it's an SDK. So your business logic runs in the context attached to this SDK, and the SDK, not you, the developer, but the SDK takes care of the protocol back to the temporal service that's going to deliver to you all these resilient services. So you connect to temporal service as a backend, you get retries, you get event-driven architectures, you get CQRS, you get event sourcing, you get state preservation, all of those things. Now, what can you write your business logic in? Whatever you want. we have SDKs in all of these different languages. So there's no DSLs, there's no DAGs, there's none of that. You just code in the language that you want to code in. So that is kind of the high-level overview in slide form of Temporal. Joseph, do interrupt me if there are any questions. But with that, I think I'm just going to move straight over into demo to show you. We're going to start with Temporal, using it as a business application, and then we'll bring Pulumi back in. So I'm going to go ahead and jump over to that now. So let me go over and show you that what I have running here is up in the upper window, I have my Temporal service running. And what I'm going to do is I'm going to run in these two windows here. I'm going to run my Temporal application. In here, I'm going to run the application itself. And in this particular case, I am running one of our sample applications. There'll be a link to this at the end of the presentation, called the money transfer app. It's a very simple application that just does a withdrawal from one place and does a deposit to the other. But of course, you want to kind of sort of treat that as a transaction. If something goes wrong with the deposit, then you want to revert back and take the withdrawal back out, that type of thing. So I'm going to run that application, and I'll show you the code for that application in just a moment. And then this is now running the application, waiting for somebody to say, I want to do a transfer. And so rather than putting some kind of fancy UI in front there, I'm just going to run this application. Let me hide this little window. I'm going to run this application just from the command line. So what this is going to do is it's going to come up with a random amount with two random account numbers, and it's going to invoke one of those money transfers. So keep an eye on this window up here. Down here is the window where I'm starting the transfer. So I start the transfer, and you'll notice here that it said, okay, it finished the transfer. And up here you can see that we've deposited $37. So we withdrew $37 from an account. We deposited $37 into an account, and there you go. We've also recorded the transaction into a database. You'll see where that database comes in just a moment. So let me show you the basic code for this so that you can see you're just writing your applications. So here's the money transfer function. So what you can see here is that I am invoking a withdraw function, then I'm invoking a deposit function, and if something happens with the deposit, if there's an exception, then we say that it's failed, and we're going to revert we're going to refund. So that's what you can see here. So we're going to do a recovery. So that's the basic code. So you'll notice that I didn't have to preserve state or any of those types of things. Now let me show you what it looks like from how it executed from the temporal perspective. So I'm going to go over here into the temporal UI. I'm going to refresh this. And what you see here is you see this transaction that just happened. So again, $37 from and to accounts. And you can see here that we did a withdrawal, we did a deposit, and because we were successful, we recorded the transaction in a database. And of course, that took a long time because the database is running up in AWS. So, I mean, a long time is still only about a second, but it took long compared to the withdrawal and the deposit. Now, I want to show you what happens. I have been saying that it will do retries on your behalf. What I'm going to do is I'm going to come in here and I'm going to throw a wrench in things a little bit. So in this deposit activity, so remember, I did a withdrawal and then I did a deposit. In the deposit, I'm going to change this flag to false. I'm just injecting a little bit of failure in here. And you'll notice that because activity should succeed as false, we're actually going to throw a runtime exception. So if I come back over here and I hit Control C, I'm going to restart the application because I need to recompile it. I just changed it. And now I want to initiate another transfer. And you'll notice there that it's saying that the deposit has failed. So let me go back over to the UI. and show you what that looks like. So you can see here that the transfer is running and the withdrawal happened, but the deposit is having trouble. Now, you can decide what you want to do. You can decide how often I'm going to attempt something like a deposit. You can see here that we're going to attempt up to 5,000 times. That's for demo purposes only. And you can see here that the attempt count is chinking up. And that's because each time it's calling that deposit, it's failing. And so it's just trying again and again and again. So let me come over here and I'm going to show you something super cool. I am going to set this back to true. And I want you to notice something. I'm going to kill the worker, the thing that is there executing that transaction, that withdrawal and that deposit. I'm going to kill that. And normally, if you were just using something like Spring Retry, if you're a Java developer, your retry logic would die with that. And let's come over here to the UI. And you can see now that it's not attempting anymore. It's kind of stuck on that 8th attempt. But the workflow, the actual transaction, has not died. The transaction is still running. Now, if I restart this, so this is like my Kubernetes container died and Kubernetes restarted it. Now you can see that it completed the transaction. And if we come over into the workflow, you can see that it in fact completed the transaction. So that showed you some of that failure scenario in action, is that we had the retries. My instance, my business logic actually died. When I brought it back, it picked up where it left off. Now, we're not going to spend this webinar talking about the details of how that works. I just wanted to show you that those are some of the basic capabilities of Temporal. All right, so now let's head back over toward Pulumi. So the scenario here is that I, as a developer, have been doing the development of my business application. I've been using a local temporal, that's what's running here. So just a local temporal instance on my laptop. I've done all of the testing. I'm ready to push this thing out to prod. So what do I need to do for prod? Well, I'm not going to run against a local temporal service. I'm also going to start deploying my application into, let's say, my Kubernetes infrastructure. Now, for demo purposes, I'm going to keep running the application locally. But one of the things that we want to share with you today is a provider that Pulumi has made available for Temporal Cloud. So let me introduce you to Temporal Cloud very quickly. I'm going to go into the slides here. So we started in dev. Temporal Cloud. So first of all, let me tell you that Temporal is entirely open source. It's MIT license. It is not open core. Every feature that you see on Temporal Cloud is available in the open source. What we do with Temporal Cloud is we're just really good at running this distributed system at global scale. So you can see that we're running Temporal Cloud across these different regions: Europe, the Americas, and Asia, Asia Pacific. And we have all of the, concurrency locking and all the distributed systems practices built into that. So as I take my business application out into prod, I want to use Temporal Cloud as my temporal backing service, not my local one. So how do I do that? Well, we're going to use the Pulumi IDP. So I am ready to deploy this app to prod. I need a prod environment. So I'm going to come over here into templates.
Oh, I could do this part.
So I, as the developer, would start here and I would pick up the temporal resources. I'm going to hand it back over, the screen share back over to Joseph, because I don't actually have access to his account. And so he's going to show you this part of the IDP and he's going to explain it really well. So do you need me to stop sharing?
Yes, please.
Is that here? Stop sharing. Yep. Okay.
And there was one question in the Q&A. I'm trying to find out what the question meant, but if he does respond, feel free to.
Okay.
And I'll go to my screen share. So just like Cornelia was saying, I am in that org. I've navigated to Pulumi IDP and templates. And here we have a repository of all the available templates in our organization or Pulumi organization. Now you might be saying, well, where do these templates exist? And they exist in a GitHub repo that we have connected to our Pulumi organization. So down here at the bottom, we have integrations, and you're able to set the source for those organization templates. In this case, my source is my temporal resources here. So if I go back to templates, search up temporal, I will see that option. And essentially this private registry that's available in Pulumi organization is a reflection of what you have in that GitHub repository. So in this case, I have connected my temporal resources repo, and I've written a very bare bones README, but this is basically the README that is available to that repository. And end users, or developers in this case, when they come to Pulumi, they'll be able to understand what they need to provide, what that template is doing, and what they can expect to get out of it at the end. So in this case, this is going to create a namespace for Cornelia. It requires a region as an input, and then it requires the name of the namespace as the input as well. And then last but not least, the developer will expect a web address as a result of this execution. So let's go ahead and deploy this program. So we're going to deploy this Pulumi program, which is stored in a GitHub repository, and I will show you that briefly after I deploy, through the new project wizard and through deployments, which I was mentioning earlier. The new project wizard is basically the UI, and then deployments is what is doing the work in the background, essentially. So we have a couple of options here. We have a no-code version, and we have a Git-backed version. A Git-backed version basically makes a copy of my repo that it's pulling from, whereas the no-code version executes without making a copy in a new repository. And so in this case, we'll do a no-code deployment. I've already kind of set defaults, but I can change this if I would, if I want to. I'll leave it as is. And then I will select an environment. And an environment is an ESC definition. In this case, what our environment contains is the API key to authenticate to that Temporal Cloud instance or organization and allow us to create that namespace within that Temporal Cloud instance. So I'll go ahead and select the one that Cornelia is going to use, and now we'll say create project. One thing I'll mention before I do this is there's parallels to that program model that I was talking about. So in this case, these project details are defining the Pulumi project. We also have the stack name, which is defining our stack, and our configuration is unique to our dev stack. So if I had another staging stack, I can set it to different configurations as well. And so I'll go ahead and click create on this. It's going to stand up a deployment for me. So what it's doing here is it's pulling the Pulumi image, standing up a container, downloading the necessary requirements or dependencies, and executing the code for me. So while that's working, I will go ahead and show you quickly what the program looks like. And so what I did to create this Temporal Cloud template is essentially first thing I did was I wrote the program. You'll see parallels. The Pulumi.yaml contains my high-level bits of information, such as the runtime. In this case, we built this temporal provider from using Pulumi's any Terraform provider capability, which essentially allows you to create a Pulumi provider from any existing Terraform provider. So for example, we of course have AWS, GCP, Azure, but there's some long tail ones that we have, some niche software or SaaS services that might not have a Pulumi provider. If there is a Terraform one, you can go ahead and just apply that and use it in Terraform as well, or in Pulumi. So in this case, I import my provider. That provider gives me the ability to create a namespace, and then I set the necessary attributes there. So I believe this is running right now. And if we look at this, if I click main here, it'll go ahead and open that repository which it's executing. And so in this case, it has my README, and it has the same parallel that I was just showing. So this is the code, and this is what it's executing. And so now that it's done, we have our output. So Cornelia, if she was doing this herself, she can navigate over into outputs. And if I hit refresh on this, go into outputs, and she can go ahead and click this to open up her, basically her namespace. So I'll go ahead and share this with Cornelia so that she can have it. And she will have it there. So I just sent it to the chat.
Awesome.
Yeah. And I'll go ahead
Excellent.
and stop sharing.
Okay. Well, then I will take the ball back. And I will start here. So what you see here is what I showed you before. This is where we saw the temporal workflow running when it was local. So you can see that the URL here is localhost. But if I come over here, you can see that I'm now running against Temporal Cloud. I have a number of active namespaces already. And now with a refresh, I should see the new namespace. Sure enough, there it is. So I'm going to click into that namespace, and you can see the details of the namespace here. So you can see all the different API keys that are available. I can have configurations on this namespace. So the namespace is kind of the primary construct that allows you to organize a group. Now, if you remember, Yosef was talking earlier about these different stacks. So you could, for example, have a namespace that corresponds to these various stacks that you have as well. So you could have a namespace for prod, a namespace for staging, a namespace for dev. So how you structure your namespaces is entirely up to you. Within the namespace, you have all of these different policy things that you can establish. So like I said, access control API keys that are available. We also, of course, support SSL certs. You can do encryption, you can do, exports, all of those types of things at a namespace level. And then you can also see the workflows at a namespace level. So at the moment, I have no workflows in this namespace. If I were to move over to a different namespace, you can see the workflows that I previously ran, none in that namespace, but in this namespace, you can see that I was doing some testing of our demo in there. So let's go back to this particular namespace. And now I want to run my application. Running I'm going to just keep running it locally for demo purposes, but likely I would be running this on some cloud infrastructure, Kubernetes or something like that. So what we have here is that I am now going to take the information that came back from that namespace provisioning, and I'm going to set those as environment variables. So I set an environment variable there and there. My structure is still the same. Here's where I'm going to be running that business application, and that business application simply is waiting for transfer requests. So let me go ahead and run that again. So I'm going to do Maven here to run my application. And I'm going to do, and that is up and running, it looks like, yes. And I'm going to do a Maven here to execute the transaction. And there we go. And the transaction is running, and it looks like it succeeded. It recorded in the database. So if I come back to my UI here, I can refresh this page. There we go. And there's the transfer that we just executed. So again, you can see the various stages. We did the withdrawal, we did the deposit, and then we recorded the transaction. Okay. So that gives us a pretty good overview of demo 1. Joseph, am I forgetting anything? I think that was our demo 1. Anything else that you want to add?
No, I think that's demo 1, and then for the demo 2 portion, we can get into that.
Okay. So what you see here is this was demo 1. So demo 1 was a business application using Temporal as a backing service and a database. Of course, and that database is an RDS database in AWS. We demonstrated that Pulumi was able, through the IDP, to apply what sometimes is called a golden path. So apply one of these templates. And that template included a number of things. It included creating that namespace, as Joseph walked through with us, but it also created an application at the back end that is going to monitor this database. And that application at the back end is, of course, going to use Pulumi to check on the capacity, and then when necessary, use Pulumi to scale the capacity on this database. Yes, if you're doing RDS in a real world, you might just have RDS do that automatic scaling for you. But for demo purposes, we wanted to show you a simple example where you can use Pulumi. So what we're going to do in demo 2 is we're going to show you exactly that. We're going to show you an infrastructure management app. That application is something that Joseph built. He's using it, if I remember correctly, Joseph, you wrote it in TypeScript. He's using the TypeScript SDK to connect to the backing service. So that workflow, that orchestration of Pulumi is going to be durable. So all of those failures that I showed you earlier, it's going to be resilient to things like the automation going down. It's going to be resilient. It's going to do retries where necessary. So it's really about giving you durability for your orchestration. And then, of course, it's going to use Pulumi to actually do the connectivity and to do the scaling operations with the database. And I think that's headed back over to you then, right?
Correct. Yep. You can pass it right there.
Okay. So I'll stop sharing. You're good to go.
All right. My turn. Little hot potato on the screens. Can everybody see that? Let me zoom in.
You might want to, zoom in a little bit. Perfect.
How's that?
Better. Very good.
All right. So we're going to just take a quick look at my application here. A couple of the things that I'll point out is my application is doing a couple of things. So first thing it's doing is it's constantly polling the database to see its storage space, or the remaining amount of storage space that it has. And then the next thing it does is, after it reaches a particular threshold, it will trigger a resize. So this resize, what it does is it executes a Pulumi program, which updates that database for me. And what it particularly updates is the allocated storage for that database. So at a high level, that's what my application is doing. So this is intended to be a long-running workflow. So it just is constantly polling, making sure that the database is in a good, has enough storage so that there's no downtime experienced. And so what it uses to do that is it uses our activities, which we have defined, and this is where the actions exist. So let's take a quick look at our get free storage space, which is the polling portion. That's what's doing our check. And like Cornelia was saying, I'm using a client to get the metrics from the CloudWatch for that database around free storage. So I have constructed the command, and this is AWS CLI command, just using the TypeScript SDK for it. I basically provide the name of that database. So this is the one that Cornelia is writing to. and it will execute and it will sort it so that it's latest at the bottom. The resize is making use of our automation API. And so what the resize RDS storage is doing is essentially I'm providing it the Pulumi organization, the project name, as well as the stack that it should author to. And this remote workspace needs, again, my fully qualified stack name, but it takes the Git location of my code. So this repository contains the definition for my resize project, which essentially just changes the allocated storage settings for that database. It's taking some environment variables to authenticate to AWS to make that change. And then instead of going through the CLI to do a Pulumi up, I can just reference that the output from my remote workspace and call the up function on it. And so that's what it's doing when it's executing. And if we take a quick look at my organization or my temporal server here, this has been running for about an hour and a half just to drive the point, but it has constantly pulled the database as data is getting added to it. Recently, it did a resize storage database. So this was executed, meaning it tried to change the state of my database.
Yeah, and so I'll interject here. So we've deployed the application to production. We're a big bank or a big credit card company. So we are getting millions of transactions a second or a day. And so that's really what you see here is we've deployed the application to production and we're just recording transaction after transaction. And so that's why the database was growing. So as soon as we deployed it, it started growing. And Joseph, you talked long enough.
Okay, got it. Perfect. So if we look here, we'll see that it's outputting a bunch of stuff. It's recognized. Let's see, let's go up a little bit more. So briefly, I will show this. So if we go back to workflow, it's looking to make sure that, and this is just contrived a little bit, but it's making sure that the free space is greater than 40 gigs. And so it's doing the conversion to bytes for me and comparing it against the metric that I have returned from my CloudWatch. And so, it was at 15 before. After Cornelia filled it with some data, it hit 13. And my code recognized we're low on storage. I need to resize. So it triggers my resizing capability. And here's where Pulumi is being executed. So it's standing up a deployment for me. It's performing the action. And it says at the end here, Pulumi update succeeded. And since I haven't changed the code, it will continue to say it's low. But right, that's besides the point. If we look at the database itself here, this is staging. So this is my stack. If we look at the resource instance, we can see that the previous run, it was at 20. Let's see. The deployment is running here. It's still working on the Pulumi side. Let's look at the details. Yes. So interesting. This seems to have thought that, let's go to staging, maybe a little live.
Are the demo gods
the demo gods
angry?
might be against us. But I can fix it real quick. Let's see.
Yeah. So while you're fixing that, I'll chime in and say that you saw earlier how I actually stopped the business application from running. So Joseph could have stopped that Pulumi orchestration application that he was just showing you, he could have stopped that from running. And then let's say it was running in Kubernetes. Again, you had some kind of a maintenance operation. So it stopped that, restarted it in a new container, and it just would pick up where it left off. So you wouldn't lose that monitoring or that orchestration just because you had either a crash or some maintenance operation. So it's really nice with maintenance operations too, that you can cycle things and it'll just pick up where it left off when it comes back.
Correct. Yep. Yeah. Sorry. 1 second.
Sure.
What I'll do is, I think I'll just make the change here. Am I in the right one? Demo gods, don't do this. There it is. I will find. This was my issue. Forgot to add the prod. And let's. Sorry, 1 sec. Demo gods. This will work. Regardless, yeah, let's not dive down that hole. The main thing, disappointed that it didn't work, but the main thing worth noting is that once a particular amount or database location or storage has been reached, it triggers a resize. And while the resize didn't go to our intended plan, what matters really is that it did trigger, and assuming that everything worked and the gods were on our side, that it would have made the change for us. And so with that, I believe
I think you can go back to the slides. Yeah, there's some URLs that we have on the last slide if you want to just project those. And then we can take some more questions. While you're bringing that up, there was a question from Nathan in the chat asking about with the long running workflows, are there any performance concerns? And the first part of my answer is performance, of course, can mean lots of different things. So you might be, on the one hand, thinking about resources. So is it consuming a bunch of resources? And the answer is, and my first answer that I put in the chat is that no, it doesn't consume resources. It will, when you have these long running things like the sleep, Joseph only had 10 seconds in there, but if you had a sleep that went to sleep for a day or something like that, anytime that it's either waiting for something like a timer to fire or it's waiting for signals. We didn't talk about signals today, but you can signal from the outside. You can signal into a workflow. Anytime that it's waiting for anything, it can take all of that stuff out of memory. Now, of course, we have caching so that if it comes back very quickly, then it's in the cache. In the event that it is not in the cache, then we do need to regenerate the state. And so this is not appropriate for, like stock exchange transactions or something along those lines. In terms of, hey, if we're waiting, it's not, you're not going to have long running workflows for the stock trades and those types of things. But with the long running workflows, if it does go out of the cache, then it does take a little bit of time, but it's incredibly efficient because of the way that it recreates the state. And so you can come to Temporal and you can reach out to me and I can tell you more about how the state is recreated.
Perfect.
Yep, resource consumption, great. That's what you were asking, Nathan. Super.
Just answered that one.
Awesome. I see a question from Mario about more examples with Python. So we do have, I imagine you're probably asking on both sides. From the temporal side, we have lots of samples in all of the different SDK languages. These days, I'll tell you that temporal is being used a whole heck of a lot in AI stuff, building agents and stuff. And that's where there's lots and lots of examples coming out with Python in particular. That seems to be a favorite language in the AI space. So if you head over to Temporal, you can find lots of Python examples there. Yosef, I'll let you answer that from a Pulumi perspective too.
Sure. In terms of examples, we have a repo, Pulumi example, Pulumi-examples, and that contains a whole slew in all of our major languages. So you can have one in Python, TypeScript, Go. And one thing worth mentioning is that database portion of the demo that I created uses a Pulumi component. So this Pulumi component, you can think of it as an abstraction of related resources. So if you're familiar with Terraform modules, for example, this is kind of a one-to-one relationship. But the main distinction is that you can author in Python, for example, and if the greater portion of your organization is more familiar with TypeScript or some other language, they can utilize that component without having to do any changes. So they can use your Python authored, just create a SDK for Go or TypeScript from that one and utilize it as that without any issues.
Cool.
And
What else? Oh, I see something popped up in the Q&A. Let's see. Oh, not there. It looks like an excellent combo. Excellent.
Perfect. Yeah, the slides have the different repos that we used, and can certainly kind of copy and build out of those if you prefer.
Yep. Cool.
Yeah. Any other questions?
We've got like a minute or two left. So if you have a question, now's the time.
Perfect. Well,
all right. Well, it seems quiet. I will speak up and say, Yosef, it has been such a pleasure working with you on this, and what a delight to do this webinar with you. Thank you so much.
Likewise. Yeah, I'm very proud to have, I actually just learned about Temporal myself as well, so it seems incredible. And so tragically, it didn't work out all the way. It was awesome.
It was pretty close. Don't beat yourself up.
Yeah, it was really close. Thank you for everybody for joining. Hope you got a lot out of it as well. Last I checked, we had about 50 attendees. So
nice.
Yeah, we might be famous.
Awesome.
All right. Couple minutes. Let's see. There's something in the Q&A.
Oh, I see that.
Can be integrated with Copilot for template. Yeah, in the Pulumi world, what you can do is let's say you execute a Pulumi template and it creates a program for you. If there's some issue that happens during that program, you can use Copilot to help you debug that issue. So in the UI, you have the ability to debug with Copilot. Copilot can also provide a sample code as well, right? So you can have it author some code for you, and you can have that be what's deployed into Pulumi. Yeah, there's a whole slew of stuff that you can use Copilot with, and in the UI itself, it's available. So Pulumi AI has been kind of been continuously revamped, and so its ability to search your whole entire organization opens up a whole new world of like day two operations you can do with Pulumi. I don't know if there's a Copilot integration through GitHub or something for Temporal.
So, I mean, certainly like Copilot, I've been using Cursor. You saw me using Cursor. So there's all sorts of, AI coding agents that can help you write temporal code. And it's getting better all the time. Temporal is not as widely used as, say Python in general. But it's getting there. It's getting there. I would say 3 or 4 months ago, I couldn't get the coding agents to write much temporal code, and now it works pretty well. So
Great.
getting better all the time.
And that's the AI promise. For sure. All right. Looks like we are at the top of the hour. Again, really thank you everybody for joining, and hope to see you guys again at the next workshop.
Okay.
Thank you,
Thank
Cornelia.
you all. Bye.